In this video, we're going to introduce polar coordinates and look at plotting polar coordinates. Now, polar coordinates, as far as plotting them, very similar in a way to plotting x and y coordinates. So with x and y coordinates, or rectangular coordinates, our value of x and our value of y tell us if we should move left or right first, or just stay where we are, and then if we should move up or down, or just stay where we are. In polar coordinates, instead of moving left and right and then up or down, instead we can move left or right and then rotate our point a certain number of degrees or radians. So with polar coordinates, we're moving left or right and then we're rotating, as opposed to moving left or right and then moving up or down. So a couple things. First up, with polar coordinates, the origin with rectangular coordinates, where the x and y axes meet, it's called the pole for polar coordinates. Our polar axis is similar to our x-axis. Now here I have it going to the right, but it could also go to the left as well. So our polar axis is our x-axis, and we go out a certain number of units from the origin, from the pole, just like with rectangular coordinates, and then we rotate. Keeping in mind, if our angle is positive, we rotate to the left or counterclockwise. If our angle is negative, we rotate to the right or clockwise. The polar representation for points is r, the radius, how far out we have to go, and then the angle at which we have to rotate. So any point in the plane, not only can we describe it using an x and y coordinate, we can also describe it using polar coordinates, where we first go out a certain number of spaces for r, and then we rotate. So if r is positive, we go to the right, just like with positive x coordinates. If r is negative, we go to the left, just like with negative x coordinates. So again, for polar coordinates, we're going to start at the origin, known as the pole, and then we'll go out r units to the right if r is positive, or r units to the left if r is negative. And then we rotate by the amount given. And again, keep in mind the direction of rotation based on whether the angle that you're told is positive or negative. So again, polar coordinates of a point are represented by r and theta instead of x and y. In a later video, we'll take a look at converting between rectangular and polar, but for right now, we're just going to plot. So here we have a polar grid. Looks like a dartboard in a way. And we're going to start with point A is at 2 and 240 degrees. So each of these solid rings I'm going to use to represent a unit of 1, and each of the dashed rings I'm going to use to represent a unit of a half. So for A, we have 2 and 240 degrees. So we're going to start by going out 2 units to the right, because the value of r is positive. And then we're going to rotate 240 degrees, which, because it's positive, it is going to rotate into the left or counterclockwise. So here is 240 degrees, and notice it's 2 solid rings out. So here is the location for point A. Part B, we have -4 and then 7 pi over 6. So for part B, we're going to start by going 4 rings, solid rings to the left, because the 4 is negative, the value of r is negative. And then 7 pi over 6, we're going to rotate that many radians to the left. Again, it is a positive angle. Now 7 pi over 6 is 210 degrees, which conveniently I also have the conversions here for you as well. But we're going to rotate 210 degrees to the left. So let's say we got 90, 180, and now we need another 30 degrees to get to 210. So we should be right about here for point B, and that's where we are. So I usually count by 90. Each one of these, in this particular grid, each one of these radii, these spokes, represent 15 degrees. So you can use that to help you. Part C, we got 2.5 and -5 pi over 12. So we're going to start by going out 2.5 rings from the pole, from the origin, and this time we're rotating -5 pi over 2. So we're actually going to rotate to the right, not to the left. So rotating -5 pi over 2, let's see, that's going to give us 90, 180, 270, 360. 5 pi over 2, I believe, is 450 degrees, so we have to rotate another 90 degrees. We should end up right here, hopefully, and we do. So, again, pay attention to the sign, because it's negative, which means we're rotating to the right. Finally, part D, we have -3 and -pi over 4, so let's start at the pole and go 1, 2, 3 rings to the left. Negative rotation means that we are rotating clockwise or to the right. So we're going to rotate pi over 4 units, or 45 degrees. Well, here's 45 degrees, so we should be right about here for point D. All right, that about does it for this video. Thanks for watching. I'll see you next time.